So all tools tries to solve a problem, and what problem are we actually trying to solve here? And the problem is managing state and related logic across components. Sharing state and related logic in React can be a source of a lot of friction. And to understand this, let's just talk about it. Because if you think about the state primitives in React, like useState and useReducer, those are scoped to work within a single component. To be able to share that state with other components, you either have to pass it as props or you have to create a context provider. Now, you might have heard the term props drilling, and this happens when an application has a lot of shared state where a component defining some state needs to pass that state multiple levels down to hit its target component, where the intermediate components might not even care about that state. And you might think now, but that's why we have context providers. And yeah, they do solve that problem. But again, as complexity increases and you share a lot of state and especially related logic, you can get into issues with context providers as well. So for example, if you have a context provider that's only sharing state, you're pretty much set up, because if that state changes, the value of the context changes, and any consuming components also reconciles related to that. But if you want to expose some related logic as well, you might define the context value as an object. And if you do that, you get into the situation where the parent of the context provider reconciles, causing the context provider to reconcile, causing the object reference to change, and now any consuming component will also reconcile, even when the state didn't change. So you have to be careful about this, and you can solve it by, for example, using Memo, but it kind of shows the kinds of frictions that quickly occurs. Now, another aspect of this is that if you have a lot of state in a context provider, there's no way for a component to select a certain piece of that state that they're interested in. They will reconcile regardless of what state actually changed. So you can reduce the state in a context provider and split it up into multiple context providers. But now you have a lot of context providers. And also if one context provider needs state from another context provider, you have to make sure the order is correct. So again, in complex applications regarding sharing state and related logic, this has a lot of friction. And there are solutions for this already. So for example, we have these global atoms signals reducers or observables. And these are very simple low-level primitives that holds some state, and then it's possible to subscribe to that state when it changes. So for example, an atom has a very straightforward get and set method, typically. A signal has a more implicit getter-setter, where the signal itself has a value property that you can change. A reducer has a dispatcher, and an observable, like a MobX type of observable, uses a proxy to detect access to state and when it changes. Regardless from a component perspective, using a hook to consume any of these low-level state primitives, it doesn't matter. They get the initial state and they can subscribe to updates. The mechanism might be a little bit different. For example, in an observable world, you would create an observer context of the component, and you could access multiple observables without having to explicitly subscribing to each one of them. But at the end of the day, this is what we want to do. And this solves a lot of problems, because now any component can access any of this state. But there's no structure around it. We just have a bunch of floating global state values. And this is why we have been creating these global state stores. They give structure to these state primitives. And the way we've approached it is that, again, they do basically the same thing. The state primitive itself is different, but they're composed together in such a way that they represent a single global tree. It's like a monolithic implementation of state. And some of these stores, they expose logic, like methods, with the state itself. Others, they express or has a layer of logic outside of the state. This is like typical Redux, where you have a dispatcher which has some Thunk implementation to run logic, and it's like happening outside of the state. And then you have some of these that doesn't really have an opinion on how you want to interact with the state. They just compose the state itself. Regardless, the store, as it's called, typically is exposed on the provider, and any component can consume and interact with this store. So this is great. Like, I've been working on a couple of solutions like this, and it solves a lot of issues in complex applications that needs to share a lot of state and related logic. But Impact tries to make this more flexible, so that you don't get into the situation where you create a single monolithic implementation of state and logic. And the way it approaches it is by using something called reactive hooks. And just like you know hooks from React, the reactive hooks of Impact is also just a function where state and logic is encapsulated. You return the state and functionality you want to be public, like consumed by components and other hooks. But what you define that's not returned, that becomes private. So you actually have private state and logic. Now, as you know, hooks are composable. One hook can just use another hook. And that's the case for reactive hooks as well. You can define one hook and just use another hook. Now, the thing is that these hooks from Impact, they don't run within React. They're not part of the reconciliation loop. So you're not using the primitives of React. The reactive hooks has reactive primitives that you use. And you can, by default, they are globally scoped, but you can scope these hooks to be part of certain component trees. The great thing about hooks is that they don't have an opinion on what to put inside them. They can represent application state and related logic, but they can also represent a utility like the visibility API of the browser that you want to make reactive and more consumable for React. At the same time, even though it runs outside of React, it's tied to the component tree lifecycle, which means that if you choose to expose certain hooks on a page, for example, or a specific feature, when that feature or page unmounts, these hooks will know about that, and you have an opportunity to clean up whatever you need to clean up. So the way this looks more visually is that you have a reactive hook, and that hook might return some logic, but it might also just return some state, or it might return some logic and some state. And they can use each other. So the middle reactive hook can use the first one, and the last reactive hook can use the middle one, which uses the first one. Composition, hook composition. The way this looks in terms of components is that you might have a hook A and a hook B. And by default, there's a global context for these hooks, so you don't have to provide them explicitly to your React application. They will just work out of the box. In this case, hook B is using hook A. But any component can use them as well. So we have a component that uses hook A, and then a component that uses hook B, which uses hook A. But when you get to a certain level of complexity, you want to be more explicit about how you expose these hooks. So what you would typically do is to create your own hooks provider at the top of your application, where you expose certain so-called global hooks. But then when you mount a page, you will use a hooks provider specific for that page, exposing hooks designed for that page. And these hooks will be instantiated when that hooks provider mounts and that page mounts, which means you can give those hooks initial values. So you can scope your state and logic to specific pages and also features. And in this case, you can see that any of the components can use hook A and hook B because they are high up in the component tree and accessible through the component tree. But as we exposed hook C on, for example, a page, the components within that page can also use hook C. And hook C, even though running outside of React, uses the same component tree to resolve other global hooks in this example. So what the Impact does is give you a lower level primitive to manage state. It's not opinionated about its state primitives, even though it ships with its own reactive state primitives. But this is how you get more flexibility on structuring your application state and provide it to your components across your application.